As I was saying in the last video, whenever we have two terms in the denominator, one or both of which have a radical, we use conjugates to get rid of that radical in the denominator, or radicals in the denominator. And the reason we use conjugates is you have to think back to our lesson that we did yesterday, the multiplication lesson. Whenever we multiplied conjugates, remember how we got really pretty answers like 3, 10, 5 minus x? All the radicals go away when you multiply conjugates. And so that's why we're going to use that concept on these problems that have, and you can look on the page, all of them have two terms in the denominator. So that's what we're going to use. So let's go through this example together. Directions are still going to say rationalize the denominator, or sometimes they'll say simplify. So it could be either one. And in either case, it just means get rid of the radicals in the denominator. So I see there's 2. So I look at the denominator and say, what is a conjugate of this? It would be radical 5 plus radical 3. So I multiply both numerator and denominator by the conjugate, because remember, this has to be the same thing every time because it's really 1. Anything divided by itself is 1. And then in the numerator, we're going to have to distribute. So 1 times radical 5 is radical 5. 1 times radical 3 is just radical 3. And then remember how when we did conjugates, the O and I always canceled. So since we're going to be doing so many conjugates, I just tell students on these, because you've made conjugates purposely, since you already know the O and I are going to cancel, let's just do F and L. So square root 5 times square root 5 is square root of 5 squared, or you could have written square root 25. That's what I usually write. And then from L, you get a negative times a positive, negative square root of 3 squared. And remember how these cancel? Or you could have written square root 9. And remember how a square root and a square undo each other? So we just get 5 out of the radical. 2 3's under a radical come out as a single 3. And so then we just have radical 5 plus radical 3 over 2. And this you might remember. Hopefully you'll remember, because in a couple days we're going to be doing imaginary numbers. And guess how we get rid of imaginary numbers in the denominator? Same way, conjugates. So this is a really important assignment because it carries over into 6.8. So let's practice on a couple. 1 over radical 3 plus radical 6. So I see there's 2 terms in the denominator. They both have a radical, so that's my cue that I need to use conjugates to get rid of that. So the conjugate of radical 3 plus radical 6 will be radical 3 minus radical 6. But whatever I do to the denominator, remember I have to do the exact same thing to the numerator. And now I'm ready to distribute in the numerator and to just do F and L in the denominator. And again, the reason we only have to do F and L is because look at OI. Outer, negative square root 18. Inner, positive square root 18. They're always going to cancel as long as these are conjugates. So that leaves us with radical 3 minus radical 6. And I like to write it as square root 9 rather than how the book writes it with the squares. So that's F. And L, so F is first times first, L is last times last, negative square root 36. Simplify your radicals. So radical 3 minus radical 6 over 3 minus 6. So my final answer is going to be radical 3 minus radical 6 over negative 3. And you can keep the negative in the denominator, or sometimes, you know, if you want to put it up there, you just can't put it in the numerator. If you put it in the numerator, you would have to distribute it through. So you can either keep it there or put it out there in front, even with the bar. But for right now, we won't worry about that. And then check and make sure everything's simplified. No pairs, no pairs, no radical in the denominator. Isn't that beautiful? 2 radicals just turned into a nice integer. Okay, let's do another one, and then I would suggest shutting off the camera, the video, and trying maybe the next 4 on your own. But let's do one more together. Get in some practice. So we have 3 over 2 radical 7x minus 3. Oh, and one of these is on the test. Let's highlight the one we're doing, because I know there's just a single term in the numerator on the test, and these 4 have double terms, and this one's too easy. So yeah, let's highlight B. And this is number 10, I want to say, on the practice test. Let me check for sure. Yes, it is number 10. So if you look at number 10 on your practice test, looks just like this. Okay, so we are ready to go. So first thing we should notice is that there are radicals in the denominator, and there's 2 terms. So the minute you see 2 terms in the denominator, you multiply by the conjugate. So the conjugate would be 2 radical 7x plus 3. And whatever you do to the denominator, remember you do the exact same thing to the numerator. So we really should have parentheses on all this, since it's 2 terms by 2 terms. Not should, need to have parentheses on all of that. So we need to distribute here. So from the first term, we're going to get 6 radical 7x. So we multiply the front numbers. There's nothing to multiply the radical by, and then we get plus 9. So that's nice and simple. And then in the denominator, it gets a little busier right here. From f, first we have to multiply the front numbers. 2 times 2 is 4. Then we multiply what's under the radical, and we would get 49x squared. And from L, we simply get minus 9. So that can't be simplified. This can't be simplified. This can't, but this can't. And remember, this means 4 times when we go to break that out. So the numerator is going to stay the same since it's already done. And the denominator is going to turn into 4 times square root of 49 is 7. Square root of x squared is x. So 2 7s come out as a single 7. 2 x's come out as a single x. So that'd be 4 times 7x and then minus 9. And so numerator again stays the same. It's all simplified. There aren't any like terms, can't do anything there. And the denominator is going to turn into 28x minus 9. Radical is gone. So there we have it. Achieved our goal. Okay, so I would turn off the video now and work on these 4, and then you can come back and check them with me. So this one, C, is a little bit more complicated because we have 2 terms in the numerator. I think the one on the final is more like this one, where you have 2 terms in the denominator and 2 in the numerator. So everything needs to be in parentheses since we're getting ready to multiply. And we need to multiply by the conjugate. And I remember students on the final last semester messing this up because they did the conjugate of the numerator. You do the conjugate of what you're trying to get rid of. I'm trying to get rid of the radical in the denominator. So don't do the conjugate of the numerator. Do the conjugate of the denominator, which would be 2 minus radical 7. And whatever I do to the denominator, remember I have to do to the numerator. Okay, so this is another thing that tricks students a little bit. So in the numerator, I have to do the full-on FOIL. They aren't conjugates. It's 2 terms by 2 terms, so I have to do all of FOIL, F-O-I-L. In the denominator, because they are conjugates, I can just do F and L. So you have to know the difference when you have to do all of it and when you can just do F and L. So if they're not conjugates, which means they don't have opposite signs, you do the whole process. If they're exactly the same but with different middle signs, then you can do FL. So FOILing, we get 2 times 2, 4, minus 2 rad 7. Inner, we're going to get minus 2 rad 7. And remember when we did these earlier, I said don't cancel on these. So make sure you still don't cancel. They're not opposites. They do not cancel. And then we get positive square root 49. So a negative times a negative, positive square root 7 times square root 7, square root 49. And I'm going to use the room for this one over here, and I'll do that one on a separate sheet of paper. So 2 times 2 is 4. So in the denominator, remember, we just have to do F and L since they're conjugates. And then from L, we get negative square root 49. So we have a lot of simplifying to do on this one. We have like terms here. We have to pull that out. So let's go ahead and pull this one out now to save a step. The square root of 49, that's 2 sevens. So it comes out as a single 7. And let's go ahead and do this one too. Square root of 49 just comes out as 7. So now combining like terms, we can say go straight to the answer. So 4 plus 7 would be 11. Negative 2 rad 7 and negative 2 rad 7 is negative 4 rad 7. And in the denominator, we have 4 minus 7, which is again negative 3. So that one looked a lot harder than it was. It wasn't too bad. So FOIL the entire numerator, FL the denominator, clean up any radicals that need to be simplified. And 49, the square root is 7, not 7 under the radical, just regular 7. And there's our answer. Okay, so let's go ahead and write D on a separate sheet of paper. So we have radical 3 plus radical 2 over 5 minus radical 2. So again, I notice that there are conjugates in the conjugates. There are radicals in the denominator, and there's 2 terms. So that's my hint that I have to multiply by conjugates. So what's the conjugate of 5 minus radical 2? 5 plus radical 2. And 5 plus radical 2.